Hey there, deep divers. Have you ever thought about what it would be like if the day was only 18 hours long?
Whoa. Well,
That's a good question.
get ready, cause today we're gonna dive into something pretty wild.
Yeah.
It's all about how the Earth's rotation is slowing down
Okay.
and how that might be connected to the very air we breathe.
Interesting.
We're gonna be looking at this really cool article from Science Alert.
Okay.
It's called Earth's Rotation is Slowing Down and could explain why we have oxygen.
Yeah, that's a fascinating idea. It's like something we never really think about.
Yeah,
Like the length of a day.
right.
We just take it for granted.
Exactly.
But this article is saying it's played a way bigger role in shaping life than we realize.
Totally. So, okay, let's break it down a little bit.
Go.
So, we all know the Earth spins right, gives us day and night.
Hmm.
But what's interesting is that the rotation is actually slowing down.
It is.
It's like imagine the Earth has a brake pedal
Okay.
and the moon is like slowly pressing down on it
Other with this gravity.
with its gravitational pull.
Yeah.
Yeah.
Over billions of years.
Right.
This pull has been acting like a brake, and it's slowly
Wow.
slowing down the Earth's spin.
And scientists know this is actually happening.
Yeah, they found evidence that it's real.
Wow.
And get this,
Okay.
over a billion years ago, a day on Earth was way shorter,
Oh, wow.
like 18 hours.
So everything was just moving faster?
Can you imagine?
That's crazy.
Like, what would life be like with an 18-hour day?
I don't know if I can handle that.
Right. But the article also said this slowdown is happening really, really gradually.
Oh.
Like, we're talking 1.8 milliseconds every century.
So it's not like we're going to be having 10-hour work days anytime soon.
No.
Okay, good.
But over these huge stretches of time,
Yeah.
geological time,
Right.
those tiny changes get up.
They do. They do.
So, okay, we've got this slowing Earth,
Mm-hmm.
but how does this connect to the oxygen we breathe?
Right.
That's where the cyanobacteria come
Okay.
in.
Yes, the cyanobacteria.
These tiny little organisms.
Tiny but mighty.
Yes. Sometimes they're called blue-green algae,
Right.
and they were basically like the planet's first oxygen factories.
Wow.
They were photosynthesizing way before plants even existed,
Oh, wow.
pumping out oxygen.
Real trailblazers.
Seriously.
Yeah.
They set the stage for life as we know it.
So they were crucial for the Great Oxidation Event.
Exactly.
Huh.
That's when oxygen levels in the atmosphere suddenly went way up.
That's right. Billions of years ago.
Yeah, and it was a huge turning point.
Huge. It allowed all sorts of oxygen-dependent life to evolve.
Like us.
Like us, exactly. But scientists have always wondered,
What's that?
why did it happen when it did?
Good question.
Yeah, what was the trigger?
Okay, so we've got a slowing Earth,
Yeah.
and we've got these oxygen-producing cyanobacteria.
Mm-hmm.
But how do they connect? How do those pieces fit together?
Well, the article talks about this research on microbial mats
Okay.
that are found in Lake Huron.
Microbial mats.
Yeah, and these mats, they actually resemble those ancient cyanobacteria.
Oh, wow. So it's like looking back in time.
Exactly, like a window to the past.
That's cool.
So scientists have been studying how these mats work,
Uh-huh.
and they found this really interesting daily cycle.
Okay, what happens?
So at night, the surface of the mats is full of microbes that eat sulfur.
Okay.
But then when the sun comes up, those sulfur-eating microbes, they retreat.
Okay.
And the oxygen-producing cyanobacteria, they take over.
That's like a little shift change.
It is. It's like a microbial shift change.
But the article mentioned something about a lag
You're right.
with this cycle.
Yes, there's a crucial detail there.
What is it?
The cyanobacteria, they don't immediately start producing oxygen when the sun hits them.
Oh, really?
There's a lag before they really get going with photosynthesis.
Interesting.
Yeah, it is.
So there's this lag, like a pause before they start photosynthesizing.
Right, and that's what got the scientists thinking.
Oh, really?
Yeah, like what if the length of a day actually affects how much oxygen they can make?
Okay.
If the day is shorter, they have less time in the sun to photosynthesize.
Right. Less time to do their thing.
Exactly.
So as the Earth slowed down,
Mm-hmm.
the days got longer,
Yep.
and the cyanobacteria had more time to produce oxygen.
More time to soak up those rays and pump out that oxygen.
Like a longer workday for the cyanobacteria.
Exactly. And the researchers think this might explain why the Great Oxidation Event happened when it did.
So this simple thing, like the length of a day, could have caused this massive change in Earth's history.
It's pretty amazing, isn't it?
It really is. But it makes you wonder,
It's that.
if longer days mean more oxygen, wouldn't we just keep getting more and more oxygen over time?
That's a great question. It's not quite that simple, though.
Okay.
There are a lot of factors that control oxygen levels.
Right.
It's a complex system with a lot of moving parts.
So we're not going to be breathing pure oxygen anytime soon.
Haha. No, not quite. But this research does show that day length might be a much bigger factor than we thought.
Wow. It adds a whole new layer to our understanding of how the Earth works.
It really does.
Okay, so we've got this link between the length of a day and the Great Oxidation Event.
Mm-hmm.
But the article mentioned another oxygenation event that happened way later.
Oh, you're talking about the Neoproterozoic oxygenation event.
Yeah, that's the one. Hundreds of millions of years after the first one.
Right, that's right. And it was another big jump in oxygen levels.
So are scientists looking into whether day length played a role in that one too?
You bet they are. They're thinking that this connection between Earth's rotation and oxygen production might be a pattern throughout history.
So the slowdown could have affected oxygen levels multiple times.
It's possible. It's a pretty fascinating idea.
It really highlights how things that seem totally separate can actually be connected.
Exactly. And that's what's so cool about science.
Yeah.
It's all about finding those unexpected connections.
And this research is a great example of how different fields of science can work together.
Absolutely. It's combining physics, planetary mechanics with biology and the study of these ancient ecosystems.
It's like a big scientific puzzle.
It is.
So we've got this amazing connection between the length of a day, these ancient microbes, and the air we breathe.
It's pretty mind-blowing.
What does it all mean for us, though?
Well, I think it's a reminder that even the things we take for granted, like the length of a day, can have a huge impact on life.
It's true.
I
We're
mean-
part of this massive system, and our existence is tied to the rhythms of the planet and even the cosmos.
That's a beautiful way to put it.
It really makes you think, what other hidden connections are out there just waiting to be discovered?
It's exciting to think about, isn't it?
It is. It shows how much we still have to learn about life on Earth.
Absolutely. We're just scratching the surface.
Yeah, it really is amazing to think about. We're not just watching this all happen. We're part of it.
We're part of this incredible system.
Yeah.
And it's humbling to think, that by studying these tiny little mats in Lake Huron,
Right.
these scientists found this connection that goes back billions of years.
Mm-hmm.
I mean, who would have thought that the length of a day
Right.
could be linked to the air we breathe?
It's crazy. And it's like you said, it's that scientific curiosity
Right.
that drives these discoveries.
Exactly. It makes you wonder
Yeah.
what other crazy connections are out there.
Right. What other things are we taking for granted
Totally.
that might have these huge impacts?
Exactly. What other mysteries are waiting to be uncovered?
So, okay, let's recap what we've learned today.
Yeah.
The Earth's rotation is slowing down because of the moon's gravity.
Uh-huh.
And this slowdown might be why we have oxygen in our atmosphere.
Right, thanks to those ancient cyanobacteria.
Those little guys really changed the game.
They did.
It's mind-blowing to think that something as basic as the length of a day
Right.
could have such a huge impact on the evolution of life.
It shows how interconnected everything is.
Yeah. And it makes you appreciate the delicate balance that makes life on Earth possible.
Totally. The length of a day, the air we breathe, the evolution of life, it's all part of this amazing tapestry.
Well said. Well, on that note, we'll leave you to ponder this cosmic dance of Earth, oxygen, and life.
Yeah. Let those thoughts swirl around.
Thanks for joining us on this deep dive.